Welcome everyone to the, I guess this is our first real session, DocCon 2018, minus the general session. Yeah! Yeah, people are excited for Abby. Happy to announce Abby Uller. The F is, I believe, silent. She works for AWS, and she's going to speak on creating effective container images. Give it up for Abby.
Hi, everyone. So thanks for coming out. So I'm Abby Fuller. I work in developer relations or technical evangelism for AWS or whatever the cool kids are now calling it. I can't keep track, so I just pick a random one every time I write a deck. So basically just a fancy way of saying that I used to be a DevOps engineer, and I guess I still am, like emotionally a DevOps engineer. But now I get to talk to cool people like all of you about how you can work on your infrastructure and your processes and stuff like that. So super excited to be here again. I know that the session just says it's creating effective container images. So I submitted the abstract, but then I made it the remix. So okay, so without further ado, I have some similarities. So people that have seen me give this talk before, I think that the basics in every talk are really important to everyone. So whether you've been using Docker for quite some time or whether you're just getting started and you're here to learn kind of all the basics, I think talk should be for everyone. So we're going to start off with some of the basics. We'll get to some more advanced stuff at the end. I've learned my lesson on trying to take verbal questions because no one likes to. So I'll probably wrap up around 5 minutes early, and then I'll answer questions up here. And then those of you that would like to stampede directly to lunch should feel free to stampede directly to lunch. But if not, I'll be up here answering questions, or you can come visit me at the booth. So starting with some of the basics, first things first, I think we need to talk about how layers work and how those impact how big or how small your container images are. So container layers, everyone can always tell when I've made my diagrams myself because they're all just in PowerPoint. And I'm pretty sure, no one told me this when I took an evangelism job, but that like being able to pretend Photoshop things in PowerPoint is one of the greatest life skills that I've ever acquired. So what are container layers? So you start off with your base, right? And that's a stack of read-only container layers. You can't do anything to them. They're just kind of the way they are already. And then on top of that, you get a pretty thin, or hopefully thin, read-write layer. So that's where everything that you go during your Docker build process, that ends up there. So any files you download, anything you do, anything you install, that ends up in that hopefully relatively thin read-write layer. So why do you care about how many layers you have, right? So more layers mean a larger image. And a larger image means that it takes longer to push and pull from a registry. It takes longer to build. The smaller your images are, the faster your deploys will be. But it also means that your attack surface is smaller, right? So everyone, I think, should always build with security in mind, whether they're a dedicated security person or not. And the less packages you have for someone to attack, the smaller your attack surface will be. So there's less things for you to have vulnerabilities in. There's less things for you to have a problem with because you just have less of them. So how can you reduce them? By the way, PowerPoint supporting GIFs is a really great thing that's happened to me. So it's now made all of my files too large to email, but I think that's worth it. So please enjoy my GIF selection. So how can you reduce the number of container layers that you have, right? So just like kindergarten, sharing is caring. So use a shared base image wherever possible. So if you're writing in Python and you have a couple different containers, you can use a shared one that has all of your Python dependencies. Also, we talked about that relatively thin read-write layer. Limit the data that you write there. So if you install a package, use it to install something else and then never need it again, you can download, install it, use it, and remove it all in the same layer without committing to your final image size. You can chain run statements, which we'll look at in detail in just a couple of minutes. And finally, you want to prevent breaking your cache for as long as possible. So try to hold off using the Docker cache until you absolutely have to break it, because everything after you've broken the cache gets built again. So a couple basics on building minimal images. So the very most basic thing of all, so a Docker file, and I'm glad that I'm the first session today, so if you didn't know what a Docker file was, now you know, and now you know for all the other sessions too. So a Docker file is a series of instructions for building your image. It usually follows the format, so run this, add this, copy this. That's it. So that's kind of your recipe for what your container actually looks like. Everything that's inside of it, everything that you need to run your applications, your application code itself, it's all described there in the Docker file. The size of your base image is also the kind of the first thing that matters after that, right? So from Ubuntu latest, in that example, that's my base image. That's the very first thing. And that determines that stack of those read-only layers that I'm building my own additions to the container on top of. So that's the first choice that we can make that determines how large my final image size will be. By the way, so this is okay. And when I first got started with Docker, more years ago, I guess, at this point than I'd really like to admit in public, but this is something that I would have done, right? So the same way that you image just a regular, like an EC2 server or a virtual machine, you use the operating system, and then you install everything that you need on top of whatever operating system you started with. And I think it's a really common pattern for people to do that with containers too, right? You start off, you install the operating system that you're familiar with. So for me, that was Ubuntu. And then you do all of your actions on top of that. But containers are not quite the same as installing on just a regular virtual machine or an EC2 instance. You can change things up to make quite a bit of difference, right? So the first up, you can choose a different base. So that might mean using one of the base images that's designed for a more minimal image. So something like Alpine is a really common one. And then if you look at the numbers, right? So my Ubuntu one, 81 megs. And just by switching to Alpine, my Alpine base is just over 4, right? So by just changing that base that I built all of my additions on top of without optimizing anything else, I can save myself quite a bit of space. And you care about space, right? Because although it's not a very kind of, I guess, sexy thing to talk about, right? What happens when my 10 gigabyte container image or my 2 gigabyte container image, what happens when not only do I have one of them, but now I've continuously deployed and integrated all of my container images, and now I have hundreds. So everyone might have 2 gigs, but what happens when you're looking for 200 times 2 gigs, right? You don't have 400 gigs. At that point, you're adding more instances, you're scaling up, you're trying to optimize. And just by keeping in mind how much disk space you're using, you can save yourself quite a lot of time. And in the case of people that are on call, you can save yourself being woken up at 2 o'clock in the morning. So this is something that happened to me, by the way, which is why I bothered writing this talk at all, right? Is I was on call, I had just started with Docker. I actually probably wrote something extremely similar to this. Different email address, same image. I built it. I was like, this is great. It's so organized. I've commented all of my lines. I'm using the same operating system. All the developers will be happy with me. And then I ran out of disk space. Not just on one instance, but on all of them. So now I'm a disk space evangelist, and I go around telling everyone else how they can save their disk space. So slightly better, right? I can choose a different distro. So I can either use that minimal base image, or I can use something that's either just a different distro, or I can use something that's specifically designed for the language that I'm writing in. So that might mean switching from an Ubuntu image to a Python image, or from a Debian image to the Alpine image, or using the official Go image or the official Ruby image. There's lots of different options there, right? And some of those might start off from a smaller place, but it also might mean that I have to install less extras on top of that, which also saves me time and space during my build process. So there are some examples, though, right, of when you might actually want a full OS, right? So we're looking at some of these minimal ones, so Alpine, but sometimes you do actually want the full one, right? So one of those is security. So not just downloading things from GitHub that someone else wrote. You might have compliance that you need to worry about. Not everyone works at a startup, so you might work in the banking industry or the healthcare industry, and you might have compliance requirements on what kind of image that you can use. And a really, I think, commonly overlooked one is ease of development. When I'm using the more minimal base images, it doesn't always have the same kind of package manager that I'm used to. It doesn't have a lot of the things that you don't think about. So how many people have tried to install an application and then realized 15 minutes in that it turns out that they needed something called Build Essential? If you're not raising your hand, you're lying to yourself. So there's all kinds of little things like that, right? There's these packages that they're not named something that you would think, hey, I need that. And although in retrospect, it does say Build Essential on it. So maybe I should just put it everywhere. But there's all kinds of packages like that it turns out that you need. And their requirements, or they secretly turn out to be C libraries that is somehow powering everything on the internet. But if you're using a minimal image, some of those things aren't there anymore. So there's more work that goes into setting up one of these minimal images for you to base it off of. So there's a trade-off between the space efficiency of space and how much work it takes for you to set that up. Plus more features. So we just talked about package managers and other little libraries and things that you don't think about, but they're not always quite the same when you're using the minimal image and when you're leaving behind the operating system that you're used to. So back to our basics again. So once we have our Docker file, all we need to do is build it. So that will both run our application, and we'll be able to see how big it is once we make our changes. So I broke down the pieces of what Docker build looks like. So the first part is the build command, so Docker build. Next you have the tag flag. So I'm going to name it something friendly and just going with its Docker ID. I assign it a name with that tag flag. So I've named mine DockerCon because I have not become any more creative at naming things since leaving full-time engineering. And then the little dot there, which I have totally left off multiple times, is the path that you're building. So F is for flags. And I've had a couple people that always come up to me every time I give this talk and say, but Abby, you did not include all the flags from my particular distribution. And I'm here to tell you that if I included everyone's flag from everyone's distribution, although it would be extremely egalitarian of me, it would not be a very interesting talk. So F is for flags. I've only included a couple Docker ones. Your mileage may vary. Right? So if you're using a distribution that I haven't talked about a ton in this, if you're using a different package manager, there are lots of different OS and package manager specific flags that you can use that also impact image size. I've given some of the most common ones, some of the more widely used ones, but there are tons out there. So if I haven't listed yours individually, it does not mean that it is not wonderful and it does not exist, but simply that 40 minutes is not time for all the flags in the world. But all flags matter. So a couple ones that affect your final image size that you can use from the Docker daemon. So cache from, so you can base your image off another image. Compress will compress your build context with gzip. I do have asterisks in here, by the way, and they're footnotes. But my footnotes are mostly on different slides. You can do no cache, so you'll ignore the cache, and we'll talk about cache in a second. You can use squash. So squash is still, as far as I know, still experimental. It squashes all of your new layers into a single layer. If you don't know what build context is, I didn't either. So I wrote a slide on what build context is. So what's build context? So when you call Docker build, your current directory is the build context, and that's what gets sent to the Docker daemon. So you can see how much context you're sending for looking for that build context message. So in this case, I'm sending 187 megs and change. So the more context that I send, the bigger my build context will be and the larger my final image size will be. So avoid building in directories that have tons of extra files or junk in them. The larger that it will be, the larger your final image size will be. So build context is important. So this is the slide, by the way, that now every time I talk for AWS, Werner says that all I do is make Wu-Tang jokes. And I guess it's kind of true. So I'm unwilling to take this slide out, even though it's the remix. Very funny joke. Cache rules everything around me. It is great. Ha ha. But first, some frequently asked questions. So yes, that is the official Wu-Tang font. I found it on the internet. It is official, though. So if you're wondering why my logo looks so much better than DockerCon Austin, it's because I got the official font. Everybody's welcome. What's my favorite Wu-Tang song? It's Protect Your Neck. I did not wear my Wu-Tang shirt because it was dirty, because I wear it all the time. But good song. Listen to it. My Amazon PR rep is somewhere, but have I ever been sued for copyright infringement on my Wu-Tang slide? The answer is no, but please don't tell. So, for good. back to cache. So starting from the parent instruction, so Docker cache is really important, right? And it's a little funny. So the way that the cache works is that starting at the parent instruction, so the first one, Docker will look at each following instruction to see if it matches the cache. And then once we've said this giant overarching rule of cache, here are now the following exceptions to the cache. So add and copy will look at checksums for the file, and it will look to see if the checksum matches. The checksum does not match, the cache is broken, you re-download the file. Other than add and copy, only the string of the command itself is used, and not the actual contents of the file. So unless you're using add and copy, the contents of the file will not be looked at. Once the cache is broken, every subsequent layer is then built again. And then I think the usual caveat here is, what happens when I have a command like pulling from a Git registry, where the string of the command does not change, but what I want to do changes? So a lot of people do that by passing in a timestamp, or they break the cache themselves. So there's ways to get around that, but in general, these are the rules that you want to follow for cache. So you can hold off on using the cache as long as possible, right? So I can chain my run statements, I can use my layers a little bit more effectively to make sure that I can pull from the cache as long as possible. But I want to keep it, because once I've broken it, every subsequent layer is rebuilt. So let's talk about how we can make our images better. So here's our original Ubuntu image. Again, this is fine. It builds. It works just fine. You can run this. You can use it in production. Don't, but you can. It installs things. It does what it needs to. It gets my application code there. It runs my Python server. It's just fine, but we can optimize it a little bit. So our first small changes, right, is that I can base it off of a Python version of the Alpine base image. So this has some packages that I need. It's a little bit more minimal. And you'll see that some things disappeared. So I have a run statement that's running apt-get update and then apt-get install, and my favorite build essential, Python pip and Python dev. So those were some packages that I needed specifically for Python. But once I moved to a base image that was designed for Python, I could get rid of that second run statement, because the packages that I needed were already there. The Python Alpine image already has things like build essential. So I can make one little small change, gets me some pretty big results. Next up, the fewer times I can invalidate the cache, the smaller my image will be. So in this case, I can copy over my requirements.txt file a little bit earlier. That means that I'll only do it if the actual requirements.txt have changed. Mic check. There. Good? Sweet. Ta-da! OK. So the longer that I can wait before invalidating the cache, the smaller my final image size is going to be. I can also use my run statements a little bit more effectively. So in this case, so it's a little fragile, right? So the double ampersand connects commands together in bash. So if I run apt-get update, double ampersand, apt-get install, I basically chained everything into one run statement instead of several. And that's different from how you do it in a regular distro, right? Because ordinarily, I'd say, let me make this as clean and as readable as possible. So I'd have multiple run statements. I'd probably comment things. It's a little less readable, but by adding everything together in one run statement, I'm creating less layers. So that's one run statement instead of a couple, so one layer instead of a couple. There's also some other commands like switching user that will add layers that you wouldn't necessarily think about. So if you're using a language like Node that has a Node user, and then some things need to be installed as root and some things need to be installed as a Node user, try to switch the fewest times as possible, because it will add a layer every time you switch. So here's an example of that, where I've added a user and then switched to it. Then I've switched back to my root user at the end. There's a different order that I could maybe do that in to minimize the amount of layers that I'm creating. So more stage is more fun. So the previous pattern, so as of a couple years ago, and I think this has been in beta for a while, so I think some people are still using the dockerfile.build or dockerfile.final, or however you wanted to name things. So there's two kind of patterns for building your images in multiple parts. So the first one, or the second one, or it's really the new one, I guess, is multi-stage builds. So that's doing separate stages in one Docker file. So you can copy artifacts from one stage to another. You can pick up from a certain point in the build that you left off in another part. results in a smaller final image. I think especially good for languages like Go and Java that have a pretty significant tool chain that go into building the actual binary that you're running as your application. The original way of doing this was with separate Docker files. So for a lot of people, that's like dockerfile.build and dockerfile.final. You can pass the direction to the actual file that you want to use at a specific context with --f. In that case, you build and then copy over the artifacts yourself. Still results in a smaller image. It's a little bit more complicated. It's a little bit more cumbersome because you're now maintaining 2 Docker files, and you're responsible for the copying on your own. So they both work. I would say that multi-stage builds are a little bit easier and a little bit cleaner. So here's an example of a multi-stage build. So from Ubuntu as buildenv, I'm installing make, I'm adding my application, I'm running make on it, and then for my second Docker file, I can copy over from number 1. So I'm running from BusyBox, I'm copying over my context from my previous build stage, and then I'm just running it. So that second final one that I'm actually running is significantly smaller than it would be if I kept make and I kept everything all in one file, and a little bit easier than it would have been the previous way where I did 2 Docker files. So if you're still skeptical and you're not quite sure on why you should switch from dockerfile.build and dockerfile.final to multi-stage builds, there's a really good blog post by Alex Ellis. It also provides the examples and the also excellent official Docker documentation. So I included links, which are the teal colored things in the slide deck. So when Docker posts the slides after this event, you should be able to follow along with all the links on your own time. In general, actually, the Docker documentation is really excellent. I assume because I've had to answer a lot of questions on like, how does Docker networking work? And how do Docker images work? So the documentation is really excellent. So in general, that if you have a question about something in the Docker daemon or how images work or how to build things, I really recommend starting there first because it's very, very, very thorough. And it's a really great place for you to start, whether you're just getting started or whether you've been working with Docker for a while. So Docker's not just for Linux, though. Windows containers as well. So this was announced a couple DockerCons ago, I think in DockerCon Austin. There's a couple tools out there to make the transformation easier for you. You can convert an existing Windows image. There's a command called convert to Dockerfile. You can also convert from VHD. Windows, not quite like Linux, though, so you have to be careful what you build. So there's a couple directories that you want to avoid. Building any of those paths will make your image extremely large. You also want to avoid installing things with MSI. So MSI installations are not particularly space efficient. So it's not the same as a Linux distro where you can add, use, and remove the installation file all in the same command. With MSI, it will save a file for uninstall. So the same way that it works when you're on an actual Windows machine and you can like right-click to uninstall and it's really smooth. It's also because it leaves files behind. So adding, using, and removing all in one in run statement won't work quite the same for Windows as it does for Linux. So I am not a Windows expert, though, by the way. There's tons of people out there that are much better at it. There's a guy named Elton Stoneman who, at this point, I can make another really corny joke and say he literally wrote the book. So I did, yeah, it was funny. See, this guy left. So I think what's really cool here, and what's the takeaway, though, is that I can build and run everything exactly the same, regardless of what distro, OS, whatever it is. Once I've built it, once I have that container, I can just use Docker build and Docker run. It doesn't matter what I'm using, right? I mean, there are some exceptions, right? But it doesn't matter whether it's Linux or Windows. I can build it and run it exactly the same, regardless of what's inside the box. So the more you know. So let's get language specific. So a couple of things to think about before we dig in, right? So use the right tool. Not every language needs to be built the same way. Where possible, use things like multi-stage builds or multiple Docker files if you want. Build an artifact and run it if it's pretty heavy. Your official languages, the official images can be quite large. That's for a good reason, though. So if you think about a language like Ruby, where every gem needs many other gems, the official repos, the official images tend to do a lot of that for you so that you can use that official image like I did in my first example with Python, that the language images tend to have a lot of kind of the basic requirements that you need to use that language. So it can often make them a little bit bigger, but it's for a good cause. So it's a trade-off, once again, between your minimal image and the things that you need to run a language with that image. So a couple of examples. So starting off with Golang, because the gopher is the cutest. Thanks, Ashley McNamara, for a cute gopher pictures. So compile first, then copy the binary over. So here's an example of building using go build, then Docker build my file. Then I can use it from scratch, so I can copy everything over and then just run it. If you haven't encountered Scratch before, Scratch is a special empty Docker file. So you can use it to either build your own base image from nothing, or you can use minimal images that Scratch will just run the binary for you. So you can use your full operating system to build a base, and then you can just use Scratch to run that binary that you've produced at the end. So here's an example on that, and then I've once again included a link at the bottom. So if you're looking for more details on how to work with Scratch, follow the trail of little blue links. So Ruby images can be extra huge. So we just talked about the Ruby gems. They've actually done a ton of work improving this. So I see the official images get smaller and smaller. Using a new base for Ruby can pay off quite a bit for you, but it does lead to quite a bit more work. So you'll have to install a lot of the dependency gems that help you run the gems that you need. So there's an example, and you can see that I'm using APK from Alpine, and I had to install some of those Ruby dev packages that otherwise I might have access to already. So Node.js. So my previous job before I came to Amazon was at a Node.js shop, and I definitely ran into this one. So you can use Docker ignore the same way that you can use git ignore, so to exclude files from being built. So a good example of this is npm debug.log, which has so many things in it and turns out to be huge. You can also cache your node modules. That way you're only going to run npm install if your package.json changes. So some ways that you can make these a little bit more smaller and a little bit quicker to build. For Java, I think it's one of the best candidates for multi-stage builds. So here's an example of using from our Maven base image as build, and then copying over my context from the build. That lets me build my artifact in one stage and then run it in the second, more minimal stage. So let's look at what we just learned in practice. So, AKA steal Brent's Docker file. Please and say that in your own head, like you'd say Wheel of Fortune. So please imagine for me, if you will. So let's look at the original. I included a link. It turns out that when you copy and paste the whole Docker file, it's too big to fit in PowerPoint. So I didn't copy and paste the whole thing. But here's what I did. So I pulled it from Brent's GitHub. I did Docker build. I named it client. It ends up being 568 megs. So pretty big. Not super big. Too big, though. So what can we do? So first things first, we can swap out the base image. So it's gone from using Ubuntu 14.04 to Debian Stretch Slim. That gets me from 568 megs to 388 megs. Or I can use a slimmer base image, so switching to Python 2 Alpine. That gets me from 388 megs to 300 megs. So pretty significant jumps every time. So the base image was probably our biggest win. I could optimize a little bit more on top of that by switching to an even more minimal base image. I can remove my pip cache, and I can do extra layers. That gets me another 25 megs. I can reorder all of my run statements to use my cache a little bit more effectively, and that gets me down to 162 megs. And I think the thing to note here is that I didn't really change anything materially, right? I changed to a different base image, which is probably the biggest win and also the most amount of work. So I changed that. I got a little bit more by changing to an even more minimal image. And then I basically just shuffled some stuff around to use my cache a little bit more efficiently. So not a huge amount of work for something that's now almost 400 megs smaller than it was when I started. So that's more disk space that I can use for other fun activities, like not this Docker file. It'll build a little bit faster. It'll pull a little bit faster from the registry when I'm deploying it. So some pretty significant wins for not a significant amount of work, which is the best kind of win. It's not just about image sizes, though, right? So making the most minimal image on the planet will only matter so much. So you also have to clean up after yourself. So there's two built-in commands for Docker. So there's image prune and system prune. Both can be used to get rid of things like unused and untagged images and volumes and things like that. So clean up after yourself. And when you think about how we used to deploy things, right? We used to deploy, for a lot of us, monoliths. And we didn't deploy it very often. So you used to talk about people that deployed once every couple of weeks or once a month or quarterly. And everyone saved up all their changes. It went through QA, they tested it, they worked on it, they talked about it. Then you did this big, giant release. And I think one of the best things that's come out of the whole monolith to microservices story is people deploying smaller change sets much more frequently. And that's good, because I can tie it back more easily to something that's actually broken my build if I needed that, or it's a little bit faster, it's a little bit easier to roll back. Things aren't as tied together anymore as they were in a monolith. But the end result of that is that I often have lots of artifacts that are left behind from all of my deploys, because I've gone from deploying maybe once a week to maybe many times a day. So think about how many extra containers and images and volumes that leaves behind when I roll out to my new deployment. So as important as it is to build minimal images, it's just as important to clean up after yourself as you go. So use image prune, use system prune. You want to put safety first too. So there's some tools out there that can help you. So both paid and open source. I really like the Aqua Microscanner Community Edition. I think they also have a commercial product. I haven't used the commercial one. There's Security Scan from Docker. You can use it with Trusted Registry. There's some open source ones, so Claire from CoreOS. So there's lots of tools out there. You could look into the depthless images from Google. There's lots of tools out there to not only help you make minimal images, but to make sure that you're safe doing it. Because a minimal image that you just download from someone's random registry also doesn't solve the problem, right? You want to be safe about what you download from the internet. You also want to garbage collect. And also because I love any excuse to use a GIF of Oscar the Grouch, so it's perfect. So beyond kind of system prune and image prune, you want to clean up after yourself. So generally, most orchestration tools like ECS or Kubernetes, they have built-in garbage collection where you can customize it in most cases. I included links to the documentation. So for both of those, you can pass flags in to garbage collect more frequently or more aggressively or more files or more images. But beyond system prune and image prune, you want to lean on those built-ins to help you clean up after yourself and use the least amount of space as possible. If you want to go a step beyond that, there's third-party tools out there. So one that I've liked in the past is Spotify GC, which I assume stands for garbage collector. So there's lots of things out there to help you clean up after yourself and to keep your environment clean as well. I think kind of beyond that too, if you leave a bunch of kind of extras behind you as you work, even your minimal images will eventually eat up all the space that you have in all of these cluster hosts. So what did we learn? So if you have one takeaway, it's that less layers and smaller layers are probably more. And in this case, more means smaller. I can share layers where possible. I can choose my base wisely. So I can either build my own, or I can use one that's specifically designed for my language, or I can use a more minimal one. You want to keep it simple. So in pretty much every package manager, there's something like no install recommends. So that's what I would use in Ubuntu. So most package managers try to be helpful. So they'll recommend a bunch of packages that you probably need in order to run the one that you have explicitly said you want to install. So there's some things that you can do to make your installation process a little bit more space efficient. So one is not installing all the recommended packages. Another one might be pinning the versions of packages so that you don't pull for a new one every single time. So you can do some extra things to help make your package manager a little bit more efficient also. And you want to lean in your tools to help you. So things like Docker Security Scan or the continuous image assurance from Aqua or these garbage collector containers. There's lots of tools out there so that you don't have to build all of this yourself. So you can run a minimal and secure and resilient container environment without kind of having to do everything in Bash or in EC2 user data, which is probably what I would have done. So there's so many more cool tools out there to help you. So lean on those. And then finally, it's a trade-off, right, between how minimal you want your image to be and how much work you're willing to put into making it small. So that is all. So if you would like to stampede out the door to lunch, now is that moment. If not, we have exactly 5 minutes left until the official end of the session, and I will be right at the down here answering questions if you are so inclined. So thank you, and I hope that you enjoy the rest of DockerCon.